Hi there, welcome back. In the previous video, I had posted the following question. By mistake, I had forgotten to give the width of the river. In the comments and the description, I had instructed to take the width of the river as D. Now to solve this question, set up x-axis along the river flow, y-axis along the man's intended motion direction, and the origin O at the point where the man starts to swim. Now consider a point P having coordinates 0, y on the line of motion of the man such that y is less than d by 2. That is, he has not yet reached the midpoint. Now as the speed of the river increases linearly with y till d by 2 to a value u0, the flow speed at P will be u0 by d by 2 into y or 2 u0 by d into y. The governing equation for the man is given by Vme is equal to Vmw plus Vwe, where Vme is the velocity of the man relative to earth, Vmw is the velocity of man relative to water, and Vwe is the velocity of water at that point. As the man swims across the river, Vme should be along y-axis, and the flow velocity Vwe is along the x-axis. So, to form the vector triangle for the relation Vme is equal to Vmw plus Vwe, the vector Vmw must be forming the hypotenuse of the triangle as shown. Now in this vector triangle, the hypotenuse has a magnitude v and the side representing the flow speed has a magnitude 2 u0 by d times y. Thus, the magnitude of Vme will be square root of v square minus 2 u0 by dy whole square. Now for Vme to be along the y-axis always, because the question asks us that the man has to swim across the river, we must have the hypotenuse v to be larger than the largest magnitude of the water flow, which is u0. Hence, for this we must have the condition v greater than u0. What happens if this isn't satisfied? We will analyze this later. For now, let us assume that this is true, that is, v is greater than u0. The vector Vmw should always keep on tilting towards the negative x-axis as the man keeps going forward till the middle, and then this vector will start tilting towards the y-axis as he crosses the midpoint. The velocity triangle just repeats in reverse order on the second half of the motion, and therefore we can safely say that the time taken in both halves of the river will be the same. Now as the man moves along the y-axis, we have Vme as the derivative of the y-coordinate, and therefore y dot is equal to square root of v square minus 2 u0 by dy whole square. Separating out the variables, taking dt on one side and everything with y on the other side, and putting limits 0 to d by 2 where half the time is taken and the time has limits 0 to t by 2, we get the time as d by u0 sine inverse u0 by v. It's a simple integration. If you look up the tables, you will be able to integrate that. Now you can also see from this expression why the condition u0 less than v was important for this. If not, the sine inverse expression will not be defined. So are we done with this question? No. You remember I had told you that we have an inherent assumption u0 less than v here. So what happens if u0 is equal to v or u0 is greater than v? What happens then? Is the man able to cross the river? If so, what is the time? For this, you have another day to solve it. Happy solving!